Alright, so after explaining the way we can choose a system, so let's do a problem. The problem states like this. We have a mass m block of 5 kg. It's coming up with a velocity of 3 meters per second square, velocity initial. And then it's hitting a spring which is initially at length 0.6 meter at rest, or relaxed length, and then it's pressing it until it goes down to 0.4 meter from the ground. The spring stiffness we have been given is 1600 Newton per meter, and the relaxed length is 0.6 meter. Now, what is our goal here? To find, for the first part, the goal is to find the velocity right here, final velocity. To find the final velocity, now we choose something called system. What is the system here? So that we can choose anything we want as a system, but the best thing to do is choose this block, the spring, and the whole earth as a part of system, because it will make us easy to solve our problem. Now, after choosing that as our system, we'll say, let's say what are our initial states and final state. Initial state is the block coming out with initial velocity of 3 meters per second. The final state is it being at 0.4 meter from the ground. Now, having said that, let's set up our energy equation. What is our energy principle? Change in energy equals work done. That means energy final equals energy initial plus work done. Now, what is our energy final? We have a final kinetic energy of the box, because we have a velocity final, with a potential energy due to Earth. Because why? Because Earth is a part of system. Also, we have potential energy due to spring, because it's also a part of system. Equals energy initial equals kinetic energy initial, the potential energy due to Earth initial, potential energy due to spring initial, work done, W. Now, I have set these two values equal 0. Why? Because initial potential energy is 0, because initially there is no displacement of the spring. Also, the work done is 0 because there is no external force. There is no significant external force acting, so that we can say the work done is 0. Now, having said that, we divide by m and rewrite our equation like this. So, this is what we're trying to find. Our initial velocity is 3 meters per second, so it's coming from the top. Hi, our initial height, is what? Which is 1.2 meters from the top. Our final height is 0.4 meters from the ground. That's where the potential energy height is required to plug in the numbers. So and then our K is 1600 Newton per meter stiffness of the spring. Then our displacement of the spring is what? Initially our spring was at 0.6. Finally it is at 0.4. So the displacement is 0.6 minus 0.4, 0.2. So after solving, plugging all the values and solving for VF, we get VF equals 3.43 meters per second. So this is how we can find the final velocity. Now, the second part of the problem says, well, now the box comes from the top, hits the spring, then goes up and reaches some maximum height. So what is that maximum height? Now in this case, we can use the energy principle. But one thing that we got to take in consideration is when the box goes back after hitting the spring, then the spring comes back to relaxed length. What does that mean? That means the final potential energy due to the spring will be 0, because there will be no displacement. Also, at the maximum height, the box is at rest for a while. That tells us that the final velocity will be 0. Now, taking that in consideration, and our system will be the same as before. Our initial state is the block on the top, final state is block further on the top after leaving the spring. Having said that, in our energy principle, note that it's exactly we write exactly the same thing as before, but there is a difference. The difference is that our final kinetic energy will be 0, because on the top, at a maximum height, the final velocity is 0. Potential energy due to Earth final is there, and there is potential energy due to spring final will be 0, because as I said, at final position, the spring is back into its equilibrium position. Kinetic energy initial will be there. The potential energy initial due to Earth will be there. The potential energy initial due to spring is still 0, because initially at this state, when the block was coming down, the initial state, there was no potential energy because our spring was at equilibrium position. Work done is still 0 because since our Earth, spring, and block is a part of system, there is no any external force acting. So the work done is 0. Now, having said that, after solving, cancelling out mass on all sides, and plugging in the values, we're trying to find HF. So VI square initial velocity is coming from the top. We right here is 3 meters per second square. G is 9.8. Initial height is 1.2 meter. And I'm focusing on these values because I will be doing this problem, this exact problem, in a separate way too. So on doing that, we get HF equals 1.66 meter. Now, the second part of the problem, finding the maximum height, I've done this exact same problem, but in a little bit different way. The difference is that in this case, my initial state is different. Actually, my initial state here is same as my final state on the first part, when the block coming up, hitting the spring, and reaching at 0.4 meter from the ground. So this final state I've said is my initial state here, And the final state of this problem will be the same thing, the block going all the way to the top, where we're trying to find the maximum height. Our energy principle will be same, and our energy equation will also be same, but there will be one major difference. What difference will there be? Well, in this case right here, our initial spring was in equilibrium position, but in this case we've supposed that our initial state different. The spring has been contracted by 0.2 meter because it was initially at 0.6, now it's at 0.4, so it's been contracted by distance 0.2 meter, right? So having said that, our initial spring potential energy will not be zero. This one will not be zero, but our final kinetic energy will be zero because our final state is on the top where the velocity is zero. Our potential energy due to Earth final will be there. Potential energy due to spring final is zero because our spring final state ends at equilibrium position. Kinetic energy initial is there. There is a potential energy initial of the Earth. Now this part right here, which I was focusing on, the potential energy initial of the spring will not be zero because our initial state is different in this case. Now having said that, our work done will still be zero. I'm trying to solve. The one thing I want to focus here is our initial velocity. Now what? Initial velocity is not 3 meters per second like here. Because why? For this state, our initial velocity is the final velocity of the first part of the problem, which this part, which we found to be 3.43 meters per second squared. It's somewhere here. Yep, 3.43 meters per second squared. So this will be our initial velocity here. And then our height will be, initial height will be 0.4, final height will be, that's what we're trying to find. And everything K will be there, SI, the same thing, 0.6. That's minus 0.4, and after solving for that, we'll get height same as 1.66 meter, which is exactly the same as we found in the second problem. So in this way, this part shows that no matter what state we choose, if we have the energy principle written down in the proper way, we can solve the problem to find the particular values. So these all part explain my concept earlier about the choosing system, using energy conservation, also the energy problem involving springs at the same time. Thank you very much.